This is for Algebra 1. This is section 3.4, finding and using the intercepts. So the whole goal of this lesson is another way to graph a line instead of a slope-intercept form. Another way to graph the line is finding the X and Y intercepts and then graphing it that way. Before we start though, I want to go over this form, a standard form of a line. And the standard form of a line is this: AX plus BY equals C. In this format, that's what we call a standard form, where A, B, and C are real numbers. And A and B both can't be zero. A and B aren't zero at the same time. Because if A and B, the value of A and B, if those are both zero, then you wouldn't have an equation at all. So here's some examples so you can understand this format. So here's one. 3x plus 2y equals 12. Well, the A term, this is A, your 3 is your A, 2 is your B, and 12 is your C. Okay, it's just a format. The X and the Y are on the same side. You've actually seen this before when you've had to change it to slope-intercept form. Here's another one. 4x minus 3y equals 24. Well, the A term is 4, the B term is negative 3, and the C term is 24. Here's another one. X equals 9. That is in standard form. So let's think about this. The A equals 1 because there's a 1x. B, well, that's 0 because there's no y term. And C equals 9. What about this one? Y equals a negative 4. Well, the AX, A is 0, B is 1, and C equals a negative 4. So just know that these two equations are in standard form, and actually this one's also in slope-intercept. No, it's not. There's no x, excuse me. So these are lines that are in standard form. Okay, so we're going to find another way to graph this equation, graph these type of equations, without having to change it to slope-intercept form. There are times to where it's easier to graph using what we call intercepts. And so the first thing we need to do is find the X and the Y intercepts. Well, first of all, remember what they are. Well, an intercept, remember it crosses the point. So Y-intercept is where it crosses the Y-axis. So the X-intercept crosses the X-axis, and the Y-intercept crosses the Y-axis. Now let's think about how that happens. How do you get a point on the X-axis? Well, to find the X-intercept, in order to land on the X-axis, you have to find the X-intercept, make or substitute zero for y. So your ordered pair is going to be x and 0. So you're going to be going right or left x amount of times, whatever the number is, and the second number is always going to be 0. To find the y-intercept, substitute, spelled that wrong. Substitute x, 0 for x. So the y-intercept is always going to be 0 and then a number, whatever your y value is going to be. So this comes into play when we get to the examples. That'll make a little bit more sense. So our horizontal and vertical lines, graph when y equals 4. Well, we've done this before, and I said, okay, make a table, and y is always 4. No matter what x is going to be, y is always 4. So the y equals 4. That means the y-intercept is at 4. 1, 2, 3, 4. And then if you think of slope-intercept form, the slope is 0. But in this case, negative 2, 4, negative 2, 4, 0, 4, 2, 4. So whenever you have an equation like that, don't think it's just one point. Y equals 4. No matter what the x value is, y is always going to be 4. So here's another one you're going to encounter. X equals a negative 2. Well, if that helps you to make your table, x is always negative 2. Y can be anything. Negative 2, 0. I always pick like negative 2, 0, 2. So x is going to be a negative 2. negative 2, 2, negative 2, 0, negative 2, 2, or yeah, negative 2, sorry, not earlier one. And there's going to be your x equals negative 2. So whenever you have your x or y equaling a number, it's not just one point, it's the entire line. Okay, so you're going to see examples like that. Other ones now. This whole section is talking about intercepts. So another way to graph this equation. Now we could change this to slope-intercept form and graph it with the y-intercept and the slope. But there's another thing that you can do is calling using the intercepts. Now I like to use the intercepts when these two, the A and the B, are factors of the C, or vice versa. Somehow they easily go into it. So our first step is find the x-intercept. Okay, so find x-intercept. Make y equals 0. So when we do that, we have 3x plus 4 times 0 equals 12. Well, that's going to be 3x equals 12 because 4 times 0 is 0. And then x is going to equal 4. So when y was 0, our x equaled 4. Okay, so our x-intercept is going to be 4, 0. 1, 2, 3, 4, 4, 0. Now, find the y-intercept. So to find the y-intercept, make x equal 0. Okay, so when we do that, we have 3 times 0 plus 4y equals 12. I'm going back to the original equation. So that's 0. 4y equals 12. Y equals 3. So that ordered pair, y equal 3 when y equal 3 when x is 0. So when x is 0, y equals 3. 1, 2, 3. So that's another way that you can graph your line. You have your 2 points. Take your straight edge. Usually, guys, when you are hand graphing, graph all the way through the given coordinate plane. Okay, so when you're graphing, don't just stop at these 2 points. You need to continue all the way through. Okay? All right, so now let's try this one. B. Now again, to find the x-intercept. So always list those though. The x-intercept, kind of like x and y-intercepts when they're kind of easy. What you can do is your x-intercept, your y is going to equal 0. So your y is equal to 0. So you have 2x, negative 2x equals 10. So your x-intercept is going to be negative 2x plus 5 times 0 equals 10. So you have a negative 2x equals 10. X is going to equal a negative 5. So your x-intercept is negative 5. Your y-intercept, if x is 0, just by looking at this, your y is going to equal 2. So if you're still with me, go ahead and write pumpkin pie up here in the top, just so I know you're with me. Okay, so I'm going to make x equals 0. So for my y-intercept, my x-intercept was negative 5. My y-intercept would be negative 2, 0, plus 5y equals 10. 5y equals 10. Y-intercept is going to be 2. Okay, so the y-intercept is going to be 2. 1, 2. Take your straight edge if you're hand graphing these. Go all the way through. Don't just stop at those 2 points. Go all the way through so then you can see other combinations, other ordered pairs that are on that line. Again, what this line represents are all the solutions or solutions in this coordinate plane that will make this equation true. Okay, let's try this one. Our x-intercept. Now don't freak out about the fractions. So if you really think about this, our x-intercept, if y is 0, what does x have to be? Well, if y is 0, that term's gone. So we have 1/2 x equals 4. Half of what is 4? Well, half of 8. So the x-intercept is 8. You know, I just now thought of, you're probably going to also have to probably see those ordered pairs. So that's going to be 8, 0. So in case they ask for the ordered pair, that's what they're looking for. What's the ordered pair here? So 8, 0 is your ordered pair. Now your y-intercept. Cover up your x. If your x is 0, your y-intercept, this is going to be a negative 8 times y equals 4. Now be careful with the equation like that. I'm going to go ahead and write this one out. Y-intercept. The x value has to be 0, but be careful with this type of problem. This is saying the negative 8 times what gives you 4. Now you're going to have to divide. Many people are going to miss this. Make sure you do y equals negative 1/2, not 2. I can see a lot of people putting 2 here, but you're saying, you know, negative 8 times what gives you 4? Well, half of 8 is 4, and that's a negative, so it's a negative 1/2. So be careful. It's a negative, the y-intercept's negative 1/2, so if you're going by ones here, it's going to be like right there. So this is going to be a very flat line almost. Okay, so your y-intercept. Now again, after I graph this line, I'm going to write the ordered pair for that y. So the y-intercept is going to be negative 1/2, 0. Okay. Again, this is just another way to graph equations. I like to use intercepts if these numbers all work out nicely, meaning that they're either factors of the c or even multiples. Like this one was a multiple of 4. So that kind of worked nicely. Now again, so your x-intercept here, x-intercept, that means y has to be 0. So if y is 0, I can just kind of cover that up, and I get 4x equals 24, x is equal 6. So x is going to equal 6. And then when y is 0, when x is 0, y is going to equal 8. So the y-intercept, when x is 0, so that's going to be 3y equals 24, and y is going to equal 8. I'm just going to go back because I think they're 10s. Okay, and then graph that line, and then go ahead and write the ordered pair on those two. So this ordered pair would have been 6, 0. This ordered pair would have been 0, 8. Okay. So graphing by slope-intercept form, using the intercepts is actually pretty simple. And just don't freak out if there's some fractions. Just think about what you have to do there. Okay, now, the next thing you're going to have to do is really put this in play in modeling what the heck the x and y intercepts represent and what they mean. So with this example, we have a car owner record the number of gallons of gas remaining in the car's gas tank after driving a number of miles. Use the graph below to answer the questions. So we have numbers of gallons remaining in the gas tank. So here's the number of gallons. Here's the number of miles driven. Okay. So we have to look at this. What does the x-intercept represent on this graph? Well, this x-intercept is 500, 0, meaning that this person, this car owner, can drive 500 miles on like once the gas tank's empty. So this driver can travel 500 miles before the tank is empty, before running out of gas. You're going to be driving soon. I would not recommend getting down to 0 gallons before running out of gas. Okay, what does the y represent? Y-intercept represent on this graph? Well, here's the y-intercept. And so at 0 miles, 20 gallons. So they had 20 gallons. There's 20 gallons. 20 gallons of gas in the car. Now, what does the point 212 represent on the graph? Well, 212, now this is kind of hard to see because the lines aren't here, but what this is saying, 212, so what that is saying, and is this point a solution of the graph? Okay, if the point is on this line, then yes, it is a solution to the graph. Now the point 212, that means at 200 miles, there's 12 gallons of gas remaining, okay? So for 200 miles driven, that's driven, 12 gallons of gas is remaining. You didn't use 12 gallons yet. Remember, this is saying what's remaining. So at 0 miles, 20 is remaining. At 500, 0 is remaining. At 200, 12 gallons is remaining. So that's what's remaining, not what he's used. So really pay attention to the labels. Okay, so down here, let's do another one. Again, this is another car one. The graph below shows the relationship between the number of mid-size cars in car dealers' inventory and the number of days that started the scale. So the mid-size car, what does the X Intercept represent? The X Intercept represents days after the sale starts. So 15 days after sale starts, they have no cars left in the inventory. No cars are left in the inventory. What does the Y-intercept mean? The Y-intercept means at this point that there's 150 cars in the inventory to start with. At start of the sale. Okay, what is the point 1050? Well, 1050 is a solution to the graph, so yes, it's on the line. 1050 represents after 10 days, 50 cars remain in the inventory. After 10 days, 50 cars remain in the inventory. Okay, so that is about what you want to do with interpreting the X and Y intercepts. So that's really important. Okay, now you're going to be able to start on your 3.4 assignment.